It's a Newton's second law. Important to have a good feel for this. All right, so just make sure we have. So let's have a look at it. Right, so writing it. You should be able to write it like that. Okay, so force is proportional to the rate of change of momentum over time. It's equal to a constant k, and k is 1, as we just saw from our proof. Okay, now that particular form isn't in the tables, but it's very useful to have. Okay, because that's effectively Newton's second law. All right, but let's have a look at it and make sure we're clear on everything. Okay, effectively, if we want the force to be small, right, as we often do, so if we're catching a ball, we want the force exerted on the hand to be small, right? We either want the change of momentum to be small or the time to be large. Think about it, fraction, make sure you're clear on this. If I have a fraction 1 over 2, and if I increase, if I want to make that fraction smaller, okay, I have to either, let's take a better example, let's say 3 over 6. If I want to make that fraction smaller, I either make the denominator bigger or I make the numerator smaller. So in other words, numerator smaller, that's a smaller number, denominator bigger, that's a smaller number. So make sure you're clear on that. So over here, if I want to make the force, which is effectively the full fraction, if I want to make that smaller, okay, I either make the momentum smaller, because force is proportional to delta mv. Now often that can't be done. Okay, you can't make the change momentum smaller if a ball is being thrown at you, because the ball has a momentum and it hits your hand and it'll end up with no momentum. So that's usually not a factor, but the factor is the time. Okay, the factor that you can affect is the time. So when you're catching a ball, remember what you do, you bring your hand back as you catch the ball. Okay, so you increase the time. It's all about, if you want to decrease the force, you increase the time, because force is inversely proportional to time. Right, that's the one you have to watch. Right, okay. If you want the force to be large, you want the time to be small. So there's clips at the end of this now and you're going to look at them, okay, because it's the weekend, right? Okay, and I want you to be absolutely clear on that. If I want the force to be small, I make the time big, because F is proportional to 1 over delta t. Okay, if I want the force to be big, I make the time small. Okay, so you've two clips that you look at. To make the time small, to make the force small, that's when you're catching a ball in cricket or catching a ball in hurling or catching a ball in anything. So have a look at that clip. Okay, to make the time small, to force small, you make the time big. So you draw your hand back. If you're jumping off a high wall and you want the force that you feel in your land on the ground to be small, you want to make the time large. So what you do, you bend your knees. You bend your knees. Okay, it's the same thing with all of these. Okay, so that's what you do. Very occasionally, you want the force to be large, and that's what's happening with the guy with the karate chop. Okay, he wants the force to be large. Okay, so what does he do? You know, it's hard to see it. Okay, he wants to make the time small. So when you're doing a karate chop and you want to make the force large, you actually don't follow through. Okay, you try to stop it as soon as you can, because you want the force, the time that the change of momentum is happening from the maximum to 0 to be as small as possible to get the force as large as possible. Now you'll also notice in that clip that the Newton's third law, okay, the force applied to the brick is equal and opposite to the force applied to the hand, and people think that the hand doesn't experience force. Watch the clip, okay, you'll see it does. Okay, so that's that, okay, and I think we should all be clear enough on that. Now, you have a second form of this, whereas if you bring the t across, try the easiest way of doing it, we have the change of momentum is equal to force by time. Now that's also called the impulse. I don't think you'd ever get that term in second level physics. Applied maths people know it all. You're this is just sitting in the sun time for you, okay? Right? The impulse. Now, sometimes you want the change momentum to be large. So the obvious situation there is, let's say kicking a football or hitting a golf shot, okay, right, okay, or hitting a hurley in a slitter, okay. You want the change momentum to be large. In other words, you want the ball to go as fast as possible when it leaves. Okay, so you want if the change momentum is large, the momentum at the beginning was 0. Momentum, the larger the momentum after, the greater the velocity. So that's what we want. So we want the change momentum to be large. Now these are both directly proportional. So the change in momentum is directly proportional to the force. So let's get clear on that. Okay, so in other words, if you make the force larger, the change in momentum is larger. kick the ball hard, okay, in non-physics terms, okay. The greater the force, the greater the change of momentum. But the second one is the one that you would always have done unconsciously. You want the time to be large as well, okay, to get the change, because the change of momentum is also directly proportional to time. So momentum is doubled, the time is doubled. So the longer the ball is in contact with the hurley, or the longer that the ball is in contact with your foot, or the longer the ball is in contact with the cricket bat, okay, the greater the change in momentum, the greater the FT, the greater the impulse, the greater the change of momentum. So what do you always tell people? Follow through. What does follow through mean? It means the ball will be in contact with either your foot or the hurley or the cricket ball for a longer period. So that's that. Now, these are two very important ones that I want you to remember. Okay, change of momentum. Okay, force Newton's second law in that form. Okay, and usually that's about reducing forces. Okay, and sorry, this one. Right, just rearrange, but delta mv is called the impulse, and if you want to increase the impulse, you either increase the force or you increase the time. Okay, think about it, watch the clips, and it'll all make sense. Okay, bye bye.